right, here we're solving trig functions. Very basic Algebra 1 game of isolate the variable using inverse operations. However, we got a couple new inverse operations in play here. So for our first example, 6 cosine theta plus 5 equals 0. Several things happening to theta. I got to figure out what the inverse of each of those functions is and undo them in the right order. So I got a times 6, a cosine, and a plus 5. The weakest operation is going to go away first. Minus 5, divide by 6. So now I've whittled my way down to the cosine function itself. Right? What is the inverse of cosine? We just call that inverse cosine. Indicated by this little -1 nomenclature, right? These are as different as addition and subtraction, but we write them similarly, except for the little -1 there. So if I inverse cosine and cosine, it's done away with. Always have to balance my equation. Isolated theta, and then whatever happens over here, happens. So inverse cosining -5/6 is going to tell me the angle that makes that ratio. And in this case, that happens to be 146.4 degrees, simply because my calculator was in degree mode. Now, there could be infinite solutions to this, right? If I keep adding a full revolution, I keep getting coterminal angles, and those would all certainly solve it as well. So to save you from getting all those infinite answers every time, they often restrict it to being within a full revolution, okay? So they only want the angles within one positive revolution. And so this, first step, you gotta make sure is your first answer is within range. So in this case, we don't have to worry about that, right? 146 certainly falls in that range, so we're good on that count. But now this second part, I have to go looking for or searching or finding secondary answer in the mirrored quadrant. And so by that I mean cosine and sine and tangent all have a kind of a matching quadrant. Some are positive, some are negative, and that all depends on which function you're talking about. So I gotta first kind of clearly see that this is coming out of the, second quadrant here, where cosine is negative. It's positive in the first and fourth, negative in the second and third. So if that first angle is coming out of the second quadrant, I know I'm fishing out of the third quadrant so that everything will match perfectly, including the sine. So that 146.4, right, I think that's about 33.6 away from the x-axis. So I need to make sure I go 33.6 past the x-axis, and I'll get the secondary answer of 213.6, I guess. And so I'm always getting these kind of dual answers, these two answers, even though I'm restricted to just one revolution, because of that matching mirrored quadrant hunt I have to do. One more example to point out something else. Still maintaining the same range here within one full revolution. Let's say I got 2 tangent theta plus 1 equals 0. So again, first I got to take care of all that garbage surrounding my function here, right? -1, divide by 2. And then the inverse of tangent is inverse tangent, indicated by that little -1. Cancel, balance the equation. So my first theta, -1/2, inverse tangented, that's going to be a -26.6. So I got to make sure, is my first answer even valid, even within range? Now between 0 and 360, so how do I make sure I get the exact same answer? Right, not just a match congruent answer, but the exact same coterminating answer at a full revolution. So my first answer, my first solution comes out to be 333.4 degrees. And then I gotta go hunting for that secondary one, for tangents, right? So, okay, where is 333? Oh, that's somewhere down here. Tangent is negative down here, positive in the first and fourth, and so the other quadrant I'm fishing out of is going to be the second in this case. So I got to make sure, how far away am I from that axis? 26.6, and I got to make sure I go that far into the matching quadrant. So down here I'm going to have, for my second answer, 180 and back that up, 26.6 degrees. That's going to ensure I get that congruency, that matching ratio, that matching solution. And so 180 being the baseline here, minus the reference angle, 26.6, is going to be my second answer of 154. Oh, 153.4. So there's my two answers there in matching tangent quadrants.